let me tell you a little bit about something called quantitative electrolysis. Okay, so the idea behind quantitative electrolysis is you can actually figure out the amount of a reactant that you consume or a product that you create during electrolysis, right? Quantitative means amount, using stoichiometry. You say, all right, that's fantastic, but what's electrolysis? Electrolysis basically means that you take some kind of compound and you zap it, right? You apply electricity and you break it apart into its constituent elements. And the reason that I can do all of this math is because I know stoichiometry. I can relate the amounts that I get to molar masses of substances, and I can relate that to the number of electrons that are taking part in these half reactions, and I can relate the number of electrons to things like currents and charges. Okay, and so all of these are going to come together in one problem so you can kind of see how all of this works. Let's say that you had a piece of gold, maybe jewelry. Okay, I wouldn't suggest you try this at home, but if you wanted to actually get some gold out of your jewelry, what you could do is try to dissolve the gold. So there's a special kind of acid called aqua regia, which is partly nitric acid and partly hydrochloric acid, will actually dissolve gold. Okay, and so what you can do is dissolve the gold in aqua regia, convert it into Au3+ ions, and then reduce them to solid gold, okay, on an electrode of a known mass. So let's say that I do this experiment and I kind of run a current of 1.5 amps for an hour. Okay, the question is, how much gold is going to be deposited on this surface of this cathode? And I can solve this problem by doing some pretty simple stoichiometric analyses and conversions. Okay, so first, let me find the total charge. And the way that I'm going to find the charge is by saying that the total charge Q is equal to the current multiplied by the time. Okay, Q equals it. So I know that the current, I, is 1.5 amps. The time is 1 hour, but I have to do some conversions. Okay, I know that 1 amp is the same as 1 coulomb per second, and then I want to convert from hours to seconds. So there are 60 minutes in 1 hour and 60 seconds in 1 minute. So if I work all this out, I get 5.4 times 10 to the third coulombs. Now I can convert that to the number of moles of electrons that I'm transferring. And the reason I can do that is because I can say that the total moles of electrons is going to be the charge divided by Faraday's constant. Faraday's constant is 96,485 coulombs per mole. So if I divide these quantities, I get 0.0560 moles of electrons. Now, final steps, I should say, use stoichiometry, figure out the number of moles of gold that I produced. Okay, so if you remember the half reaction that I alluded to earlier, I had gold 3+ ions, which are being converted to gold atoms. So to do that, I have to gain 3 electrons, which means that for every 1 gold ion that I have, I require 3 electrons. So if I have 0.0560 moles of electrons, the ratio of gold to electrons is 1 to 3. So I should have a third as many moles of gold, 0.0187. And now the last thing I have to do is find the mass. So to get the mass of gold that I'm depositing, I can multiply the number of moles by the molar mass of gold from the periodic table, which is 197 grams per mole. So if I multiply this out, I should expect to see approximately 3.68 grams of gold on my cathode surface.